Sir,
Students with the electrical department, huh?
Okay.
yes, sir. Please begin.
Yes, sir, electrical department.
Which semester?
No, six, fourth and sixth.
Excuse me, Girish sir. Please begin. We are live.
Ah, yes, sir.
Please begin. We are live.
Okay, sure, sir. Good afternoon, one and all present over here in this webinar. That is for our challenges on distribution side. Okay. So basically today we are having the webinar on this particular topic by well-known person from MGVCL, Mr. Gaurav sir, and currently is working in India's top ranking A+ graded government power system company, MGVCL, which caters more than 3.7 million consumers, having a power distribution, maintenance, design and direction engineering expertises, in this case, which includes the operation and the integration of various power sources like conventional and non-conventional. In we can say that solar and PV and geothermal likewise, and EV charging station and static charging as well. Sir is also having the expertise in the field of designing the power system, selecting and calculating the optimum relay protection setting in present scenario of this particular power system distribution. So with the use of the smart inspired artificial intelligence techniques, sir is also having exposure in the designing and installation and operation of SCADA and DMS, which actually comprising the automation point of view, along with the line expertising in piece of designing of RMU, RTUs, FRTUs, wireless network service provider configuration, SCADA OSI software, which configuring and the live operations with the power quality data analysis are is catering power more than 1 million power consumer at Vadodara city in Gujarat. Affiliation with the IEI, that is Institute of Engineers India, as an associate member, and IEEE, he has been awarded by the Bajaj Electricals Limited in top 10 innovators in India for the designing and innovation transmission design wind and solar power generation individually. Medalist by IEI for scoring top of the Bachelor's Engineering in University. In addition to that, he is also having expertise in delivering the lectures as a keynote speaker for electrical engineering and technologies, as a motivational speaker faculty fluently as well. He has also delivered more than 1,000 lectures and practical program sessions to working staff on various topics still and continuing by the way. So far as major software is concerned, he is already aware and masters about OSI SCADA, ETAP, PSCAD, MATLAB, AutoCAD, drafting design, MyPower, PowerWord, ANSYS, KL version, etc. So this is the, I think, glimpse about Dr. Sir. Please continue, sir.
First of all, thank you, Parvard University, for calling me as an expert lecturer uh, person, and then Girish sir for acknowledging me. So I do have a short period of time, so let me start with actual topic which we are going through. So it's about such challenges in distribution power sector. Uh, Let me first start with actually the power system begins with the generation actually, because ultimately distribution is affected by the generation itself. So in recent power scenario, for generation, like you might be well aware of the recent crisis going through in India in generation wise. So that's why we are facing, but means not particularly Gujarat, but many states are facing power crisis. And if the same situation persists on, then definitely Gujarat will also affect due to the generation crisis of the fuel, because we are majorly dependent on coal. Let me say that the recent generation capacity in India is 395 gigawatt, approx 395 gigawatts, and out of which approx 236 gigawatt of energy we generate from coal-based power plants. So we are much relied on coal-based power plant, and recently due to say global crisis, the due to shortage of coal, we are daily basis we are having the power cuts due to less power generation capacities from the coal based power generation. So main challenges about the generation is about say diversing our sources of generation, just not belonging only to the fossil fuels like diesel plants, Moreover, diesel plant consumes only 0.1 percentage of our generation, but major is the coal-based plant, which I guess having the 57 percentage approx of the sharing of our power generation capacity, lignite-based, gas-based. So they are having less than 1.5 percentage of contribution for power generation. But yes, the coal-based power plant is having more than 50, say 52%, sorry, 52 percentage of sharing of total 100% power generation. So first of all, we need to diversify our generation sources. So that is the major challenge to find out the optional fuel. So nowadays we are more focused on renewable sources like solar and wind. Already hydro power plant comes into that, but hydro has seen the limitations of geographical because there is the need of construction of dam and that hilly sites. So that is not abundantly available in our like country all over the world, all over the country. So yes, hydro is limited as well as the permission to grant for it. That takes a long, too much of long time. Approx 10 years it can pass after the projection of project. It may take up to 10 years for permission and construction of them and to means reallocate the population falling under that dam zone. So itself it has some issues. So now we should more focus on wind and solar. So at present scenario, solar power plants are contributing like we are generating 50,000 of approx 50,300 like megawatt from solar, 40,000 approx megawatt from wind. So as per global trends and global policies, each and every country has demanded from UN to get at least that 50% of generation from renewable sources. So as per that, we should be going like it was pre-COVID session. It was disclosed by our PM that we are going to get that target of 175 gigawatts from solar-based power system. But yes, definitely you are well aware of this COVID situation, and now we are falling back towards by the like more than 100 of gigawatt. We are falling apart because it's just we have reached up to the 50,000 megawatt only. So yes, next trend is to first more focus on solar based, wind based means renewable like biomass, then cogeneration power plants, then small hydros, then say waste energy generation. So that is the major first challenge for all of you guys, all of us as electrical engineers. That we should be fine. We must find alternative source of that because one day the coal is going to diminish. Yes, new kind of very costly power plant as well as it also needs a very skillful person, very abandoned area. So it is also a tough thing. So first thing is we should focus on solar and wind, but there has also the challenges in that. So that is also a trend and future scope which you can elongate yourself towards solar wind because like solar is that solar generation is capable from like 9:50 in the morning up to say 3:30 or 4 in the evening. So the major challenge is to store that energy because in night time, in off time, the solar energy is not available. So it is the for SLDC purpose, you might be knowing that state load dispatch center. I have gone through that. So same is the pattern. Like the daytime, it might be generating over 500 of megawatt in daytime particular, and on like night time it could be goes up to like 20, 30. So it is very difficult to manage that load sudden changes, generation changes. Same way wind is capable like solar to we have the idea somewhat of idea that it would take some more of time to changes like it is more over constant from 9:30 or 9:15 in morning up to 4:30 or 5:30 say in evening. But for wind generation it is like you can't predict it any way. In just in 5 minutes, I have seen that wind generator power plant at Kutch, Bhuj, Mundra, Shayad, it might be giving you power generation output above like 40 megawatt, and suddenly in next 1 or 2 minutes it could go up to like 2 megawatt. So that is a drastic change for the renewable sources. So the main factor is that diversity, asynchronousness. that is increasing day by day just because of penetration of these renewable sources like solar and wind. So one thing you should focus over generation about is to like concentrate over these renewable sources, like to increase this number of renewable sources, but in effective manner. That to store the energy generated from it, harvest the energy on the maximum possible hours, so that we could have the most efficient fuel sources, and as well as it can create less and less pollution. So that is the problems and challenges from the point of view of generation system. Because ultimately the distribution companies are getting power from the generation system. So definitely we are going to affect definitely. So next thing that comes in picture is the transmission system. Once the generation has done its duty, and it's the transmission system. So, moreover, in India, transmission companies are very profitable companies, and they are doing their good work because they are just transmitting power. There are no any concern from generation point of view, any parameters of major parameters concern like voltage parameters. Fine, just they need to transfer power from various level to different level by having some sort of elements like compensator banks and whatever. So, from the transmission perspective, we are doing great in our entire country. Like our JETCO in Gujarat, in JETCO, there is a transmission company for Gujarat section, which is having like profit more than 100%, not 100%, more than 100%. So definitely a transmission system we are doing great. Then comes the distribution company from which I belong to, and which is the like end point of the power section. Yes, we are dealing with the consumer. Ultimately, the consumers are getting power from us, distribution companies. So the major challenges are at distribution companies. Uh, like say nowadays, I will say the AT&C losses, the aggregate transmission and commercial losses. So first of all, before the Electricity Act 2003, I think you might be all knowing that. Before that, it was the GEB, means in for Gujarat term, it was a GEB. In general term, it can be said as SEBs, State Electricity Board. So before that, the entire state having the only one single electricity board. So it was very difficult to handle by the only like that time only the three persons were the like chief engineers that are looking for entire the Gujarat region. So same way, the entire thing was dependent on 1 or 2%, 3 or 5%. So it was very difficult, and that time we were like doing a great loss over the distribution system before this Electricity Act 2003. After 2003 Electricity Act, it was demanded that all this SEBs, State Electricity Board, should be diversified into sectors. So that is why our Gujarat section was distributed, means distribution system should be different. So for our Gujarat system, there is one parent company, that is UNL, Nigam Board. This is Gujarat Urja Vikas Nigam Limited. Then there is a generation company, that is GSAC. Then there is a transmission company, that is JETCO. And beneath that, there are four distribution companies, zonal wise: PGVCL, UGVCL, DGVCL, and MGVCL. So that is the main agenda of that Electricity Act 2003 to reduce the AT&C losses, to like bifurcate the distribution entire company into small part of the zone. So that is how these SEBs deformed. So after that, definitely the more and more, like at that time before SEBs, there are more than like 2-3 persons were handling as a chief engineer. Now in particular MGVCL, there are 3 persons which are handling as a chief engineer. Obviously there are below subsidiaries are there, but yeah, at least now for looking to entire session, there might be like 25 to 27% who are superior and looking after the entire power sector. So definitely that was the thing, that managerial thing has improved nowadays. Then on basis of technical losses, that AT&C losses have reduced to somewhat amount, that is aggregate technical but still as per fiscal year of 1920, there was a AT&C loss of 21% out of 100%. So we are losing about 21% of power supply. So it was about 23,000 crore. That is the loss of our entire power sector in India. It is very major challenge for us, and that major caters by the distribution companies, state electricity boards, uh, because we are facing multiple factions. Like let we go in deep manner that one thing first overcome is we are the dealing with the consumer. So consumer mentality is very effective in this profession. Like at least in Gujarat it is less, but see in many states like UP, Rajasthan, due to somewhat backward mentalities, there is a number of pilferages. They are not willing to pay the bills professionally, so they are doing a pilferage. Even in we are having such, but it is in less amount. That is why we are having the best distribution companies in the entire India. So first thing is that theft, energy theft is the major concern of that. Distribution companies lost their more than like 20% of share just because of energy theft. So that is major concern of that. So it could be like mitigate by provision of something like we are doing it aerial bunch of cable, that is coated cable. We are calling it as aerial bunch of cable, that is coated cable by fibrous material. So it is not easily frangible. So it cannot be like easily used by the theft person. So we are doing that. Then ultimately the consumer we are providing power at the voltage of 433 as a three-phase voltage and 230 voltage as a single phase voltage. So and our supply system is 11 kV. For Gujarat, we are supplying from our substation. Our substations are 66 kV by 11 kV, and then by 11 kV is supplied to different kind of transformers, distribution transformers, and ultimately that cater load to our distributors. And if they are having the three-phase supply, then we are providing them 433 voltages. If they are single phase, like residential normal consumer, so we are giving them a single phase supply of 230. So that in initial time, previous time, there was a thing that number of LTs like 433 and after 11 kV and then LT 11 kV to distribution step down transformer, then up to 433. So that time LT connections, LT lines were very long. That you can see at your home coming from the poles. So LT lines were very long. So it was possible for the consumers in coming that who haven't registered consumers, they can directly hook to the LT lines that were open in previous time. So it was the scenario. But nowadays, what we are doing is we are like concentrating our transformers up to the load end. Like we are not giving much scope for theft by provision of them LT good level. So we are like distributing 11 kV up to the load end, up to the consumer society's peak. So 11 kV definitely they can't theft directly because it's 11,000 volt. So that is how we are somewhat catering to that. But still, there are losses like somewhat to LT is there is going to be definitely. So that is some point of loss. So one thing is energy theft. Then next thing is skilled person. So nowadays, like in now, the government of India for power ministry has distributed about the package of 3.5 lakh crores for new scheme that is coming. Its name is RDSS, Revamped Distribution Scheme. Okay. So for Gujarat and for particular MGVSL I am talking about, it is given about 3,700 crores. So that is having two parts. One part is changing the meters. The meters are going to change very soon, like in 6 months or one year, say max to max 2 years. So we are already in that. So that meter will be having prepaid scheme. The consumers need to pay in pre-scheme. They need to first paid their balances and then they would be catering their power. And definitely that would be giving the data to our SCADA system. Nowadays, there are general meters and for billing purpose and for doing analysis purpose. one person from our engineering department or billing department need to visit that consumer premises by one to one. So if there is a theft position or if there is a malfunction in billing position, it is very tough scheme nowadays. So I have already said that in MGVSL there are 3.7 million consumers. So that is very difficult job. So nowadays, like due to this scheme, all the meters will be replaced by the smart meters that are prepaid. So no any issues like post paying at once. Like for residential consumer, we are billing for 2 months after 2 months. So once we let them to use and after we are billing. So not of the 100% consumers used to pay their bills. Even like 10% consumers if didn't pay, so we have already supplied our units to them, but they are not willing to pay their bills. So we need to disconnect it. But still, our areas is pending with that. So that is how we are losing our commercial system. But now the trend is changing. Now we will be deploying the prepaid meter. So first initially you need to recharge your meter and then you will be cater your energy. So that is how we will be mitigating our areas. So there is no use of like we are having the debit areas. So one thing is that so that is in good zone nowadays. The future trend is like that. Then next thing, the parameters of that particular consumers will be sent to SCADA system or supervisory control and data acquisition system. So we can easily analyze technical part of view also that like the voltages they are getting like current they are utilizing power factor they are doing. So it would be very easy for us to stay at place and we can analyze the consumer number of consumers. So if the consumer contracted demand at particular like distribution company, if the one consumer has done the contracted load with us having a 5 kilowatt of, so approx he might be using or entire 5 kilowatt he might be using the amperes like 10 to 15 amperes. But see if he is using more than that as per contracted load, but if he crosses the amperes and we are getting the data live from our SCADA session, then it would be very convenient and definitely we can find out that glitch person. So definitely by parameter analysis, we can find out the pilferage as well as some technical glitches as well as some if person is not doing perfectly with the registered contracted load demand. So that is how we will be going to mitigate. The next challenge we are facing is the technical term. On the technical term, interruption, number of interruption, like power cut. So, as per the consumer's general tendency is that like state electricity boards or the government is intentionally wanting to deliberately wanting to power cuts. But that is not the fact. As we are selling the power, like as a seller, we will be definitely anyone will be any businessman will be wanting that by 24/7 they should be catering their product. So our product is unique. So each and every discom in entire India will definitely want to cater their consumers power for 24/7, because if you are utilizing that and we are charges on base of that. So if our like somewhat amount of power even for 1 hour, if hi-fi, like say a commercial building is interrupted, then we might be losing thousands of units, and we are getting charged. So definitely, that's not the thing that consumers thinks nowadays that the SEB is like wanting, but it's the loss of our actual business. So interruption nowadays is a bigger challenge for us because the load pattern has changed from ancient time to now, because there was the load condition from that most over the motors and then bulb, incandescent bulb that was having the pure resistive effect. So there was no any concern for power factor deterioration, but nowadays the major load of us is having the semiconductor devices. So harmonics and the power quality is deteriorated. So we know that the sinusoidal waveform, but nowadays we are not getting any kind of sinusoidal perfection in the waveform just because of our load pattern has changed, right from our mobile chargers to laptop chargers to our LEDs, that is LED based, semiconductor base of 9 watt even. So our measure of the load, each and everything, like motors is also going in semiconductor zone. So nowadays, that load definitely, as per your studies, you might be getting this point. A load is disturbing our power quality. So that is why somewhat we are getting more and more interruption nowadays, because at distribution level companies they are not still into the picture or into the business for power quality improvement. Yes, we are having some capacitor banks and that, but nowadays that kind of analysis is still pending with that harmonic analysis, and to mitigate such harmonics, we need to provide some compensation devices at consumer load end. But at present scenario, even not I'm talking about India, but that is the global issues. The global countries, that is even developed countries. So such issues are there. And after the insertion of so much of solar, rooftop solar, say it is the major challenge for us nowadays. So yes, definitely you could, you are from 4th and 6th semester students, so definitely you could opt for such project. It could give you good knowledge as well as you could be hired with good scale as well as good companies, because it is the demand nowadays. So that major challenge is the integration of solar with our common. So you might be seeing that solar rooftop from nowadays it is casual to each and every home's terrace. So what is happening now? Okay, we are providing phases. Say if there is a society having a 30 number of homes, so we'll be providing one phase, and if they are all single phase, just assume that. So we are providing them single phase to 10 consumers, then another phase, Y, say R to 10 homes, Y to 10 homes, and then B phase to 10 homes. That is how we like to balance the voltage system and current and load by providing such situation. So at that time the system was balanced comparatively, but nowadays what happens? Say like Y phase, they are having the 10 homes, and they are consumers are very advanced, and they all have put solar panels over their rooftop. But the phase R consumers of 10 homes and phase B having the consumers of 10 homes, they are like 1 or 2% have deployed the solar panels over their rooftop. So the definitely from morning 9:30 to say in evening 5:30, so definitely the load, maximum load of that B phase, which are having moreover solar panels consumers, they will be catered by their panels only. So they are not willing to get the power from MGVCL. They will be like mitigate their load demand from their solar panels only. In addition to that, they are catering power back to MGVCL, means the distribution companies. Yes, that is the trend. Now, our one feeder at particular Sama is getting power from consumers to us in peak time. Let's say from 11 in the morning up to like 2, 3 in evening. The feeder, that particular entire line is getting power back into our system. So that the scenario has changed nowadays. Not only the distribution company. In ancient time, that was the only distribution company which was providing power to the consumer. But now the consumers are feeding back to our system. So we are having much and much issues on protection basis as well, as because the power direction has changed nowadays. Same way, that is the one thing to you every student should look after for it. Definitely our R&D section and us, we are also doing research about that, because it's quite complicated system nowadays. So number of interruption are increasing. And another thing is, due to solar penetration of rooftop, we are unbalancing our load. So as I have said that the entire load demand by some phase has cancelled out by their solar system. So the load has disturbed. We were planning the load accordingly from our design. So we were catering load in balance system. But nowadays, our own solar system, there is no hold. Any consumer can opt for solar panels, and that has disturbed the load balancing. So that is why our transformer, you might be doing that. Transformer is the element which is prone to unbalanced load, that is disastrous effects on the transformer. So our neutral nowadays, the RYB, if the balance system is there, say R phase, Y phase, B phase is carrying the 100 amperes each, then the neutral is definitely going to have 0 amperes. But nowadays, practical, I am giving you the digits like R phase is having 100 amperes, Y phase is having only of like 10 amperes, and say B phase is having 110 amperes. So definitely like 90 amperes of current flows through the neutral of the transformer. So that is the major concern. Nowadays, distribution transformers are getting damaged more and more. And that distribution transformer is costing like our 500 kVA transformer, which is generally deployed for commercial buildings and large buildings. We generally deploy 500 kVA transformer, which is having the cost of 13 lakh, more than 13 lakh. So that is how we are losing our revenue just because of damage factor. So that is the thing one. Then next thing, once the transformer got damaged, definitely we are needing some sort of time, some sort of few hours to replace it. So that time particular we are losing thousands of units as well. So it is the major challenge. So to reduce the interruption just caused by this solar rooftop system, the power deterioration it has created to our system like harmonics and pulses and over voltages. Next thing is over voltages. Like as per our standards, we are providing single phase consumer with the voltage level of 233. But now if you are having such you can see in your meters as well, that nowadays if someone person in neighborhood they are having much number of solar panels installed on their rooftop, then you can see this phenomenon. You can see in your meters now the voltage are going beyond 260 voltage. Some consumers are getting 270 voltages. So that might damage, and that is creating damage. You might be reading in newspapers as well as in general like social media that entire societies got over voltage and their apparatus being damaged. So that is the situation just because of solar. So now we need an active system that might be seen, because if say see, there is one scope of doing such that we deploy some reactors over that near transformer center so that it might reduce the voltage level to somewhat level. So if in, but that is the scenario of solar, because when solar radiation is from 9:30 to 5, then the voltage is going to rise, but that is also disturbed because there are clouds and radiation differences in cosmos. So you are not 100% knowing that. So if we suppose we provide a fixed reactor over that part, that may reduce the voltage like 270 consumer is getting, and that may reduce the voltage from 270 voltage to 230 level. But just think of what will be in night person, because in night definitely the voltage is going to reduce to 230 standard level, because the solar radiation is going to be out from the system. So solar will be not providing the units to our system. So whatever that time, the reactor might reduce that 230 voltage level of standard in night time to again like 190 or 180. So definitely that fixed system is not going to work for our distribution system. Definitely it should be in active mode, that it should be a closed loop system. So whenever a voltage such disturbances, like as per our standards IEC, 6% of voltage variation is fine with us. So ranging in that, we can make a device that could sense the voltages at the tail end, at the consumer end, and give a feedback, closed loop feedback to such reactors to insert one by way one reactor in series, or deploy or discard the same in reverse order if the voltages are reduced. So that is one scenario. So we can make such kind of active algorithm based such apparatuses. So one thing, the voltage can be balanced. So I'm giving one topic for that project also. That is, one voltage balance is much required in future. Nowadays also the trend is same, but in future definitely it would be a major crisis for all of us. Means day by day, solar penetration is increasing and voltage levels are rising to abrupt level. So definitely one thing, if any one of you are demanding or interested in such topic, then once you should go for this project, uh, like voltage compensation that is active, not only uh, inactive base. I want it in active basis. So one thing is that then the reactive power. Nowadays, uh, due to load unbalance system, now means the semiconductor devices have negligence amount of reactive power demand. But yes, they affect on the reactive power wave. So also that is the issues with this recent trend of load. That reactive power compensation is required at the consumer end. As on date, we are just transforming the voltage, like that straight away feeder 11 kV, 11,000 volt carrying feeder coming from substation to the consumer end, having one transformer center, and that is like step downing to it 433 voltage. That's the only thing nowadays the distribution company is having. But now we are requiring capacitor bank at consumer end as well, because the load is like power factor is disturbed somewhat. Sometimes I'm being at SCADA, I have seen that to peak times for particular like industrial zone and commercial zone, the power factor is reduced due to multiple use of motors. Yes, obviously the power factor is got disturbed due to inductive effect, and that are motors basically. So commercial, there are like compressors, large air conditioning units, and for industries that are having motors for their production unit. So definitely the power factor of such feeder, particular feeders that are catering power to industries or such commercial apartments, is got disturbed to zero point 0.6 level, zero point 0.6 of power factor, or even less than that sometimes in the peak time. So definitely they will be carrying more number of current for the same their demand, and definitely that is going to increase the I square R losses as well as the life of transformers because of overheating and eddy current and hysteresis losses. So that is also a good point of research nowadays to manage the power factor. Definitely you are knowing that how to control the power factor by deploying capacitor bank, but that is now being done at substations only. But you need to guess research on some kind of small which is having less capital amount and easily adopted over the two pole structures over the nearby the distribution transformer. So such kind of device is bad requirement of nowadays society distribution system. So you can work on that also, reactive power compensation method. Then the next thing is that, okay, for interruption purpose, say we do have one offices in the, like say for city purpose it should be the area might be catering about 3 to 5 kilometers, but rural for rural section. Let me talk about when I was in Santrampur, that is on the Rajasthan border, that is having more than 45 kilometers square 45 kilometers, 45 square kilometer area, particularly falling under one subdivision. So that is one issue, that from the line begins at the substation and that is going by hills and hills up to and catering the load up to straightway 50 kilometers, and that tap lines are more than, including tap line and straightway feeder. It was having one feeder. I was having one feeder of more than 133 kilometer, say, and straightaway line was having 50 kilometers from substation. So just suppose if there is a fault after like 45 kilometers, means at the tail end. So one person need to go from this office to tail end to rectify such. So definitely the manpower is somewhat issues with that present distribution scenarios. So definitely the person need to go over that. So definitely we are more pressurizing on our vehicles like fuels to go at 48 kilometers for tail end folded. But definitely we need to clear the fold in minimum of the time. So they are going over that place, and that might be a simple fuse blown out. So just that might be a work of 5 minutes. So for 5 minutes of work, a person need to go over that. Just because there are no any smart elements at the present system. So the number of interruptions are, and definitely the manpower are disturbing due to lack of sorry, due to lack of such smart devices. So one thing, one initiation is done from our GPID side. That is, let me tell you, that is nowadays in for Gujarat we have catered. Our power ministry has catered one department that is particularly oriented to research field only. That are doing research. So they have deployed one kind of switch that is based on mobile GSM base. You can send just one message to either on or off to it. So such switches can be deployed over different sections so that less and less amount of load can be disturbed. Because what we need to do once if suppose say fault, if one fault happens on particular feeder, like having the 50 kilometer of line, and if the at 25 kilometer the suppose say fault is happened. So after once the fault happens, the entire 50 kilometer of line length got disturbed. So entire feeder, the circuit breaker, like SFC circuit breaker, trips. So entire 50 kilometer of length of feeder is disturbed. It's in power off condition. So consumers falling on that particular line are having power loss. So what we do is we are starting from the substation end to restore it. So we have put number of switches over there, manual switches. So what we do is that we just disconnect one switch. So like there is a one switch, then second switch. From substation there is a one switch and second switch. So we will be discontinuing the switch number 2. One is in still on mode, and we will be saying that power substation guy just try for one's power. So he will be sending the power. Definitely the fault is after 25 kilometers, not in that particular area. So the power will be stored up to one number of switch. Okay, because that is not having any kind of fault. So one up to that is resolved. So now what will be done? The third number of see, we have opened up the second number of switch. Third number is still on, but now one is over. So power is has reached to up to 1 point, and second is off. So now the person will go to third switch. He will open up that and now come to again second switch and then push it on. So now the power has reached to 1 to 2 switch. So number of that consumers are powered. Now next, same the proceeding is done to entire end. So let's say whenever our employee reaches up to 25 kilometer where the fault has happened, and again if he has put on the switch, then definitely again the entire feeder will be in off condition just because of relay operation. So that is how we acknowledge the fault is access. So up to 25 kilometer will be restoring the power of that consumers. So at least up to 25 kilometers the consumer has got the power. That is just because that is man hour of wastage of man hours, because one by one they need to turn over to 1 to 2 switch to on off that. So if see that if at particular one position if person is capable to handle by just their phones, means sitting over here, if I am able to switch on the switch after 2 kilometers, after 5 kilometers, after 6 kilometers, so definitely I am going to note the reduce the time of interruption, as well as I am going to know the exact fault condition. So next thing is that you should be looking for such devices IT based. Then, as per my talking to that 3,700 of crore of say provision, that was first part was having the smart meters. Now the second part is for development of SCADA system, that is supervisory control and data acquisition system. So from it you can get the entire system's data, as its name suggests, supervisory control and data acquisition. So data acquisition is important, like the voltage level at different zones, particular at feeders, 11,000 voltage feeders, at LT means at the transformers ST side, transformers LT side, and then consumers. So all the parameters like their current carrying capacities, their voltages, the power factors, their maximum levels, the cross sections of the conductors, which we have deployed, designed. So all the data which is compulsory required for analyzing purpose, or say for any kind of purpose to reduce the interruptions as well as to reduce the line losses and to protect the devices as well. So in SCADA, what we do, we like put sensors like voltmeters, ammeters, power factor meters that are basically sensors, electronic sensors, to particular 11 kV feeder starter and up to the distribution system as well as we are having the RMS, because transformer it is very these devices are somewhat large, so they are not able to incorporate on double pole structure of transformer. So we have utilized the RMUs, ring main unit. So that unit is having such kind of sensors and controllability switch. So all of them, and that is reside to nearby the transformer center. So almost the transformers data are coming from ring main unit, that is three-way, four-way, five-way, two-way, in numerous matters. So we can connect multiple feeders to such RMUs. So that is one thing, and that is a smart data capable. So we are providing their 3G connection of this service provider, and we are getting the data from it, like the face-to-face voltages, face-to-face currents, power factor, active power, reactive power. So such data from various, right from beginning of the feeder up to the tail end, we are getting from that on live basis in 45 seconds of refreshment rate. So what is the benefit of that? Say at particular this time, a particular feeder is catering 100 units live on live basis, and there are five, say five RMUs which are having, like first to four RMUs are having 20 units of live power consumption, and the last one is having only 10 units of consumption. So 20, 20, 20, 20 of 4, 80 plus last of 10. It's 90. So 90 units are live consumption from distribution end. But our say panel meter from 11 kV generation feeder, it is showing our that it has reached to 100 unit live. So there is a loss of 10 units. So we can see that on live basis. So out of that 10 unit loss, there might be line losses fixed. That is going to obviously happen just because of parameters and apparatus like transformers and cables. But some kind of theft you can also identify from this view. As in this ancient time, there was no any hold live session, but now there is a live 45 seconds hold. So now at SCADA, we can find out the pilferage or line losses on lively basis. So one thing is that. Then second switch is supervisory control. So that is one thing, that data acquisition from live data acquisition, like various parameters. And then next thing is supervisory control. So based on that data, we can control our system. Like if we find out that the last RNU is having only consumption of 10, so there is some kind of loss, there is some kind of like pilfering. So right from sitting over here, we can disconnect that the same RNU, that we can disconnect the same consumers. Even in such old condition, as I have already mentioned for switch purpose, that how the procedures are being done from our employees to restore your power. So same thing is that the RMUs are having smart switches inside. Like one there is a vacuum circuit breaker and another switch is load break switches. So that is easily controllable. That is having the DC motors. We are catering that to 48 volt of DC motors. So we can just give a command from here and we can operate the same motor, the same load, the same transformer from here up to like 30 kilometers of the range in less than 15 seconds. That is operable. So that is how now this SCADA system has reduced like first of all, the design perspective view also, there was a need of particular engineers to look after that the fuzzy on paper calculations were being done to calculate the parameters for particular loads, particular design of cables, particular design of transformers for catering demanded load. But nowadays the SCADA does it perfectly accurately on the just tip of your finger. So that is how the manpower, skill manpower has been reduced by this such SCADA system, as well as the manpower, man hour is reduced because for rectification work we can be done from right only here only. Then there is need for our employees to go over their place only and just rectify because we are getting already the fault position right from here. So the what are the advantages of SCADA system? Obviously, uh, that has need to be deployed at each and every level. Right now in MGBCL, we are having such SCADA system for only Baroda region, Baroda city region. But for this, as I have given you the about some detail about this new coming uh, scheme that is having like more than thousand of crores for such SCADA system deployment. So nowadays, no next trend, such towns falling under MGVCL like Anand, Nadia, Kudra town, Alor, Dapoy will be having such SCADA system in short time. So definitely they will be cater with good quality of power soon. But still, such communication system, such ringman unit system, such SCADA system, such software system, as the SCADA software itself is having like 37 lakh of the fees for it for 5 years or 10 years. So we are requiring to develop that in-house software, in-house devices, so that we can reduce the burdens on the distribution companies as well as they could be more effective. So each and every such section, we are need to have a great R&D work for such future challenges that has to become, that definitely are going to come. So you should definitely work for such kind of systems. And I would like to say you and Girish sir as well as, okay, if you got the chance, definitely you might be, as Parol is nearby. I'll be giving you assistance for looking such projects on live basis. We do have a great SCADA system, so you can see also there, and there is a SLDC, State Load Dispatch Center. So with that permission, we can do also that. So you can see the Gujarat's entire power section unit because SLDC is having all the data from right from generation, means particular which power plant is generating how much of units at particular time up to the load end. So SLDC is like that, works behave like that. Consumers and our feeders below the 11 kV feeder. So you might get the chance for looking out such system. If you are willing to do so, definitely you could contact me. So yeah, it is that some kind of. So definitely, I will give you like such kind of project topics for that. You can work for parameter tunings nowadays. Like parameter violations are happening, like current violation, voltage violation, power factor violation at consumer. So one topic is that. Next thing is solar penetration is disturbing our entire power quality nowadays. So you can work for that, like harmonic reduction, harmonic analyzer putting. So that is another thing. Then third topic would be like uh, less interruption system. Means the interruption nowadays are doing on higher levels. Like in monsoons, you might be seeing that number of interruptions got increased due to monsoon season. Same way in summer season due to loading, just because of number of air conditioning system coming into the picture. That has got some really issues, particular for this two seasonal effect. So there is also requirement for designing a good cables, good quality of cables, because cables are definitely having parameter disturbance like charging effect and all that. So obviously we are damaging our cables also, and physically also just digging by roads and that. So you might be looking after some alternative ways to laying of cable, designing of like transformers or our that insulators that was damaged, then dropout fuses, which is the general point of a major interruption, the failure of dropout fuses, because they are not having the particular quality or particular rated capacity. So you can also design perspective view of, also you can work on that so that the number of interruption got reduced. So yes, these kind of challenges we are facing, and yes, obviously the core point is and the major point is tempering, means the power theft. So you can work on that, that how we can reduce the power theft. So these are like, I'll majorly categorize, these are the main challenges we are facing. And if anyone comes with the bright idea, definitely he is going to have a bright future, because the power industry is now growing like hell nowadays. Because as I have mentioned, we are already just doing loss of 23,000 crores. So then just, and that is only 20% of 100%. So just see the number of amount we are dealing with. So, and the next future is about EV. Each and every, like nowadays, the electric vehicles are penetrating more and more. And in next five future, I guess, due to increase in fuel prices, definitely we will elongate towards the EVs. And day by day, the quality of EV, the charging capacity of EVs are increasing. And at distribution companies, we are also providing the charging point, charging station, charging power to EVs. That is DC. So still, that is also disturbing our power quality. So such trend is like nowadays, like they are building ships which can be run on EV. They are building aircrafts which can run on EV. So next trend is totally we will be depending on power. We are in great, and there are much and much number of challenges. By solving a simple challenge, you can contribute to number of people. You can provide a great life, great interruption free, as well as a superior facility to number of lakhs and crores of consumers, as well as you can save up to crores and crores rupees that are being lost just because of less amount of R&D. So yeah, that is great. You are in great say stream and great industry. So definitely you should look after that, and I'll be assisting you for such. If you need any kind of help, definitely you can contact me. You can get the contact from these panels. I'll be helping you definitely out for any kind of your research work or study work or project work, anything like. Thank you. If any question session, let me start with that. Yes, sir.
Yes, sir. Thank you, sir. Thank you, sir, for providing such a wonderful session. And thank you for Gaurav Sahib for providing such a wonderful session and for giving us the detailed scenario about the power and its remedies required for the solar generation to the in the particular grid point of view. So challenges as well as the remedies. So sir has also provided the knowledge about the importance of the transformer cables and the recent demands in the power sector. And water balance is another issues we have, as given this are one example, and importance along with the power challenges in this field of industry as. I think the ideas related to the recent demand, voltage, power scenario along with the challenges. So are tentative remedies which can be assessed from point of view, let's say MGVSLD, GSL, etc. So in this field of electrical engineering for the of the proper project for the final year or pre-final year or in this particular 4th-sem student. So I'm really thankful for providing such a wonderful technical session, sir. And I hope that you in future we will call you definitely for this such kind of advanced topic in this particular electrical engineering. Thank you, sir. So far as the question session is concerned, I will collect the questions from the participants and I will mail to all participants, sir. Thank you very much, sir.
Sure. Sure.
Thank you, sir. Thank you very much, sir.